Alcoholism, or alcohol dependence, is a chronic disease characterized by uncontrolled drinking and preoccupation with alcohol. One major topic of debate discusses what is most responsible for the development of alcoholism, genetics or environment. It is estimated that genetic factors are responsible for 38 to 64% of alcohol, while 36 to 62% can be traced to environmental. Risk of alcoholism also largely depends on the individual person and can vary by population. In any case, genetics seem to play a large role in determining whether or not someone is susceptible to developing alcohol dependence. It can be very beneficial to be aware of the susceptibility and plan around it. That is what genetic tests for alcoholism are important. Genes can play a large role in how you respond to alcohol. In our genetic test for the risk of alcoholism, we will be testing for two genes in particular, SLC6A3 and OPRM1. SLC6A3 is a dopamine transporter gene. This gene is associated with withdrawal seizures in patients in alcohol dependence. In the study PMID 1807024 published by the ISBRA, it is indicated that both SNPs RS27072 and RS27048 are associated with withdrawal symptoms in patients. To test for this gene, we can include the two neighboring SNPs in our SNP chip test. These SNPs are both implicated in doubling the chances of severe alcohol withdrawal. The increased chance of withdrawal is likely to result in an increased risk of alcohol dependence. These SNPs can manifest in three genotypes, CC, CT, and TT. These genes are autosomally recessive. The CC genotype is linked to increased risk of severe alcohol withdrawal. OPRM1 is an opiate receptor protein coding gene. This gene is positively related to the development of alcoholism in early adolescence by increasing teenagers' sensitivity to the reinforcing or positive effects of alcohol. This was proven by the study PMID 198-60800 published by the NCBI PubMed. It showed that out of 187 teenagers genotyped for the RS1799971 SNP, the minors who had the G allele had stronger tendency to drink excessively than those who had the AA genotype. When testing younger individuals, we would like to include a SNP chip test for 1799971 in order to determine whether or not they exhibit the G allele that is responsible for increasing a teenager's likelihood to develop alcohol use earlier on by about 52%. Testing individuals for genotype CC of SNPs RS27072 and 27048 from the DAT1 gene, and testing younger individuals for the G allele of SNP RS1799971 from the OPRM1 gene is extremely important and beneficial. The best way to solve the great battle with alcoholism is by preventing it from occurring in the first place. By educating people on their predisposition to experiencing extreme withdrawal symptoms or elevated levels of sensitivity to the reinforcing effects of alcohol, we can help set precautions to avoid these two sensations, which are powerful factors in leading to addiction. The test is beneficial because it would allow for earlier detection of risk factors, which is especially important in teenagers. By undergoing a test, a person would be able to make informed medical and lifestyle decisions, as well as gain the opportunity to inform family members about their potential risk. SNP tests has many great advantages, however they also come with limitations. SNP testing is a strong method as it can identify genes with a very small number of important SNPs, but because this method focuses only on one SNP at a time, it is hard to identify a gene whose SNPs have weak effects on their own, large effects when looked at together. This is proven by the study PMID 233-65539 published by NCBI PubMed comparing SNP-based and gene-based genetic testing methods. Not only this, but as of now, our results cannot truly be proven extremely significant in the big picture, as there are hundreds of genes that influence different aspects of one's life that could also be influencing one's susceptibility to alcohol dependency. Because of this, there is a large possibility that someone who tests positive for the alcoholism genotypes may not ever develop the disorder. Specifically, individuals who do exhibit the CC genotype of SNPs RS27072 and RS27048 from the DAT1 gene, or the G allele of SNPs RS1799971 from the OPRM1 gene may exhibit other normal genotypes in different genes that also affect alcohol dependency that may serve to cancel out the risk of severe withdrawal symptoms or sensitivity to the reinforcing effects of alcohol. This can greatly affect many ethical components that must be taken into consideration. Emotionally, this may cause someone who will never develop the disease to become paranoid of alcohol and completely avoid it. A study at the University of Rochester undergraduates, completed by the researchers from the University of Sydney, found that students had a largely negative emotional response when told they had genetic predisposition, which led to prompt out-of-control drinking habits. This shows us that just educating people, especially adolescents, genetic risk is not enough to help them avoid the problem. These genetic SNP tests only cost about $100 to $200 to determine one's susceptibility to the disease. These upfront costs may be worth it in order to prevent the cost of alcohol abuse in the long term. However, if people who take these tests respond negatively enough to turn into alcohol abuse as a coping mechanism, it could actually increase the overall cost of alcohol abuse in the long run. People are currently being told that they are going to become alcoholics, even though only a small portion of genes that affect alcoholism are being tested. There are many other factors at play being left out. But the average person does not know this, so they interpret their susceptibility diagnosis as a definite answer.